Okay, so question 5 is asking to represent the following in the form 2 to the power of p, or 2 to the power of something. So it's getting us to use our indices rules. With the first one, relatively easy. When we're dividing, we subtract our powers, so we can end up with 2 to the power of minus 2, but still to the power of 3, so I still need to have that to the power of 3. The next indices rule they're trying to test you on is when there's a power to the power of something, we have to multiply those powers, so we end up with 2 to the power of minus 6. You can just leave your answer like that, you don't have to tell them what p equals. If you put 2 to the power of minus 6, then they know what you're meaning p to be. Question 2, a little bit more tricky, because we need to put stuff into 2 to the power of something, and it doesn't really guide us through how to do that. None of these are 2 to the power of something at the moment. However, I can represent 4 as a power of 2, and I can represent 16 as a power of 2. So if I go ahead and do that, so I'd end up with 5 times 2 squared to the power of 2/3 plus 3 times 2 to the power of 4, which is still to the power of 1/3. And then if I simplify this part, where I've got a power to the power and a power to the power, I'd end up with 5 times 2 to the power of 4/3 plus 3 times 2 to the power of 4/3. And then hopefully you can see that I've got 5 lots of something and 3 lots of the same thing. I could end up putting those together, so I'd end up with 8 lots of 2 to the power of 4/3. And then I still need to represent it as just being 2 to the power of something. I need to change this 8 to be 2 to the power of something, so I'd have 2 to the power of 3 multiplied by 2 to the power of 4 over 3. And now they've both got bases of 2, so I can add the powers when we multiply. So I've got 2 to the power of 13 over 3 if you represent it as a fraction. And then I know what p is because I've written it as 2 to the power of something, so I've implied my value of p.